Suppose you came across a question on a test that asked you to graph the system of equations and find the solution of both of them based off the graph. We would start by graphing these equations, and the easiest way that I know how to do is to set up a table for your x and y's. So, for the first equation, y equals negative x plus 7, if we had the point x was 1, we'd have to plug in 1 for x and get our y, which would be negative 1 plus 7, which would be 6. We could do that for a couple more points. Negative 1. A negative 1 is 1. Oh, that's cool. We did 8. That'll give us a decent line, which we can graph over here by saying x is 1, going up to the 6 on y. We can keep doing the same thing. And we'll get a line that starts out something like that. I'll borrow this ruler over here so that we can extend our line down. Because even though we only plotted 3 points, that gives us enough to extend this line indefinitely, because our equation is to the first degree, which means it's a straight line. It has no bumps or curves or anything. So we can do the second equation the same way. I'm going to set up my x and y table over here. We use the same points. Negative 1, 0, 1. So 2 times negative 1 is negative 2 plus 1, negative 1. 0 plus 1 is 1. That would be 3. All right, now that we've got these values, we'll plug them in. Negative 1. 0 is 1. 1 is 3. All right, just like the first one, we will draw this line. All right, and if the question asked us to solve both equations graphically, we'd have to look for the intersection of the 2 lines, which ends up being right here, where the x value is 2 and the y is 5. So the solution to this equation is the point 2, 5. When you're solving, you need to be careful that you don't confuse the x-intercept or the y-intercept, because those are not the solution to the equation. It's where the 2 graphs intersect.